All right, happy Thursday, everyone. This week is JSON Web Tokens and using Passport in order to issue web tokens and in order to authenticate them so that you can make sure that someone using your service is actually a person that logged in and not some rando on the streets who's just sending you a bunch of API requests. Um, as usual, please make sure you do that sign-in form um, so I can take attendance. And we'll start off just opening the floor for any questions, comments, or concerns. And then we'll jump into a live demo. All right. I'm hearing nothing right now, but if something comes up, please feel free to interject at any time. I will also preface with most weeks, I try to spend as much time as possible putting together the demo in advance to make sure that it works. I will preface that I was not able to get to that this week, so I have an idea of what we're going to do. I think it will be pretty achievable, but we may run into some hiccups along the way, just since I haven't pre-written all of this code before and worked out the kinks. So bear with me if we run into some bugs. We'll work through them together. Um, but yeah, let's maybe jump in really quickly to a small little minimum working demo of uh, using JSON Web Tokens. And then we'll jump in to integrating them um, into our project shortly afterwards. So the project that you guys are working on this week um, is using this JSON Web Token package in order to issue web tokens and to verify them. So let's get that up and running in a new project. So we have Kangaroo, we have Node. Now going into demos. We're gonna make a JWT demo folder. npm init. Yes to all of this. And we'll go ahead and open this. Oh, sorry, I promise I won't yawn the whole time. All right, so let's make a start script really quick that will just run index.js. And let's open our terminal and go ahead and install our JSON Web Token package. We'll also install .env um, since we're going to need it shortly anyway. So this is the site that I like using. But quick overview of what a JSON Web Token is. Again, we want to make sure that anyone who sends a request to our API has properly authenticated themselves. Authentication being they are able to prove that they are a user of our system, a specific user of our system, and we know who is issuing the request, and we could track it down if they did something bad. This is in comparison to authorization, which says this person is already authenticated. We know who they are. Now, are they actually allowed to do the thing that they're trying to do, call this particular endpoint or access this particular resource? Our JWTs help us with authentication. They don't necessarily help us with authorization. A token is basically just a way of the server issuing some piece of data that has been encrypted and can be used in subsequent requests to the server while it is still valid to prove that I have already interacted with the server and I am this particular user. The server is the one issuing the tokens. It's also the one decrypting those tokens when we get them in subsequent requests and then checking the contents of the token to make sure they're valid. The goal here being that someone could not just write their own token and then submit it with the API and guess something that works. Only a token that has been encrypted by the server, since only the server knows how to do that process, is going to be valid. Anything else will be rejected. So we can play around with this a little bit. This is a site that I've used once or twice in order to try and understand these JWTs. Essentially what we're doing is we're taking a object with some pieces of data, and then we're sticking it into a little package and we're encrypting the package and then sending that package back to the user, and the user will hold on to that. And when they send it back to us, we're going to decrypt, which unboxes that package, and we get back, hopefully, that same data that we put in from the server initially, and we can check to make sure that works. So we have an encoded value for our JWT here. We have some secret, which is used during the encryption process. This belongs to the server. It's some secret that is randomly generated, ideally, and impossible to guess. And based on this value that's used somewhere in the encryption algorithm, we are going to get back this JWT here. If I were to change this, then we are no longer able to decrypt this thing, because when we get it back, we're going to get just gobbledygook that doesn't actually have this JSON structure. So let's try this out. So we have our JSON web token. Let's create an index.js file. And let's import from JWT. And we're going to import .env from .env. And let's load our .env config first before we do anything. And we're just going to generate a random string. We're going to generate one random string, which is 256 characters. Could be much shorter. And we're going to use numbers, uppercase and lowercase. And we're going to get that string. Oh, we'll keep it at 32 just for now. All right, so we have our secret. Everyone should generate their own secret. This is the kind of thing that should never, ever, ever be uploaded to a GitHub repository, because now someone else can create JWTs that your server is going to be able to understand, and someone could be very, very malicious about this. This secret, or any kind of secret, generally should belong to only the person that is using the secret, or the client or the server that's using the secret. So we have this secret. We can get this by process.env.jwt secret. And we also need to Sorry, I miswrote this package name. So let's say we have our user info, which is some user of our system. This person is trying to log in. Users sent us a request with this information. They gave us a username, which is foobar, and they also sent us a password 123. And let's say we, in our system, we're going to differentiate that this is a piece of control flow. We proved from our database that user foobar exists, and this is the right password. All right, so now what we want to do is we want to issue them a token that they can send to us in future requests so that they don't have to log in every single time that they want to interact with our API. They only have to pass this token. So we can do this by creating a token with JWT dot sign. So this is going to sign a payload, which is some data. It can be a string, it can be an object, it can be these other things. We are going to sign it using a secret, which modifies how the encryption algorithm works. Every secret, just based on the letters and characters and stuff there, is going to produce a different result on the same data. And we can also pass it some options if we want to. So let's start by signing our user info. And our key is going to be the secret. We'll keep it a secret. And then we can pass it a bunch of options as well. One option, well, there's a bunch of options that are useful. We could pick what specific encryption algorithm it's going to use. If we want to be really specific, generally, if we don't specify this, it will just pick this for us and use the recommended value. If you don't have any reason to pick something more specific, then probably don't. We can specify what encoding our data is in. We don't need to do that. The one thing that we are going to use here is we're going to use this expires in option. And this value is a number for how long this token is valid before it expires. We don't want tokens to always be valid. Oftentimes, if you're setting up a personal access token on GitHub or on GitLab or something equivalent, you'll have the option to issue a token that never expires. But you'll also get a lot of very scary warnings which say this is really dangerous. We want to usually have something that has a restricted duration so that if that token is just hanging around on our system forever and ever, a user who gets into our system can't immediately access all of our stuff. So you might set this to be like 1 day, or we'll set this to be like a week if you want someone's session to be valid for a week. As soon as this token expires, someone will have to log in again to go get a new token. I don't actually know what the format of this expires in option is. So this is not correct. Expressed in seconds or a string describing a time span. So we could do 60 to mean 60 seconds, or we could say 2 days as a string here. Let's do 1 day. I see someone specify. Yeah, so we want to expire this token after a certain duration of time because we don't want a token to exist forever and provide someone access forever. Partially, like I said, so that if someone were to come across this token and try and use it, it's unlikely that a short-lived token is going to be valid. And so if a person uses that token and tries to call one of our other API endpoints when they shouldn't be able to, that token should be expired. Another reason why you might do this is that often these tokens have data inside of them that might become out of date. Let's say I encrypted my user info and my user info had like uh, role admin in here. If this person were to have this revoked, that token still has stale data that says that they are an admin and would give them admin access to our system. And that's something that's bad as well. We generally want to be reissuing tokens pretty often. It should be a pretty seamless process. It's not a huge deal to have to do this a bunch of times. Um, but we do want them to, for the most part, be short-lived. So we're going to keep this to 1 day so the person doesn't have to log in again while they're using our site, but maybe when they come back tomorrow, they do have to. So we have signed our token by console.log, our token. We should see some really disgusting value that kind of looks like this. It'll have a couple different parts to it, a bunch of random characters. And it will be very, very long, and that is okay. Now, let's say send back to user in API response. So this up here is when a user is interacting with our login endpoint, and down here, call business logic endpoint. So not like our login and user management stuff, but this is actually the stuff that we care about that does things in our system. For our ice cream demo the past couple of weeks, maybe this is them calling the API to get all of the items in our store or to call the API to add a new flavor to our store. This is like the actual business logic of the application that does something for our business rather than this like infrastructure up here that we're writing. So now in our business logic, someone's going to hand us back this token. Token from user is equal to the token that we got. Maybe we like read this from the HTTP request header. Usually this will be given in an HTTP header of the format authorization bearer token. So anytime that someone like gets the token back, they'll stick it onto their client as a header, and then this will be sent with every subsequent request to the server. So we have our token from the user, and now we can decrypt this using JWT.verify. And you'll notice that this synchronously verifies, meaning there's no async. We don't have to catch anything. We don't have to use then. It uses a secret or a public key to get a decoded token. So how are we going to do this? We're going to verify. We're going to pass it our token from user. And then we need to use our secret again. JWT secret. I think I actually called it that here. And what else do we need? We can use options if we want to. We don't really need to specify any options here. All right. So let's print out our data at the end. User is now authenticated, and we know they are a user of our system. Let them interact with the API. I think we will probably need a try catch here, or if the verification fails, but let's try it first and see what happens, and then we'll go back and fix that. All right. So what does our system do? We have our terminal. We're going to npm start. Did I not specify this as a module? Oh, it put CommonJS for me. All right. So there's a lot of stuff going on here. What actually happened? Let's go through what we have. So we have this .env.config, which loads our .env file. Then we have this really long piece of data. So we have our user info. We sign our info and create a token, and then we print that token. So this is our really long JSON web token that someone would store for sending us again later. And then down here, we have this token again. We're going to verify it, which decrypts it using the same secret. And we have this data, and then we print the data, which is our username and our password that we had originally. And additionally, it's added some extra fields to our payload that are part of the decrypted JWT. So this IAT, I think this is short for issued at, which is the timestamp when this token was issued. In computing, for the most part, we measure timestamps in milliseconds from what's called the epoch, which is just like a specific moment in time in the 1900s when they started tracking time. All languages work the same way, so this is the number of milliseconds since then. And then down here, this is the expiration, which is when our token would no longer be valid. So, with
Well,
that
could
in
we invalidate the token before this 1 day?
mind, generally, yes. I don't know the exact system for doing this. Um, I can give you an anecdote of how we do this at my job at work. Um, but yes, it is very important that we're able to uh, invalidate a token before it expires if something went wrong. Someone got into our system, they got all of our JWTs, and we want to just invalidate all of them. Or maybe we decided that some user is a bad actor and we just want to invalidate his token specifically. You'll notice from our current setup, like we're just going to verify this token, and as long as the expiry hasn't passed, then it's totally fine. Um, we don't really have any control over the data inside of the JWT that they pass to us. So what we do, at least at work, I don't know if this is common practice or if there's some way to do this from the JWT library. Doesn't look like there's any methods for this. But essentially what we do is when we issue a token, we're going to create a token from the user data, And then we write this token to the database, which for us is MongoDB. So we have a collection in MongoDB of just user tokens that we have issued. Um, and later on, I guess we send this token back to the user for local storage when user sends API request. They give us the token as a header. And then what we do first, before we call this JWT verify, is we check in MongoDB if the token exists in our records. So this step is where the revoking happens. If I no longer wanted this token to be valid, or I had to just like dump all of our tokens and start over, then we would delete one or all of our tokens from our database, in which case this would fail. Token is deleted, revoked. Send back to user 401 unauthenticated. So basically, like we just need to store this token somewhere, and if we delete it and the token doesn't exist before we verify, then we reject the request and say, you haven't given us a valid token. We're just going to throw it away. And then once they've done that, we still want to decode the token to make sure that it's correct, although at this point we can be reasonably certain that it is. To get the user data. So we'll get back that username, password, user ID, anything that is going to be helpful for identifying the user, and stick this into the request data for use in our business logic. This is the piece that you're going to be implementing that I haven't done here, but you'll be implementing for your assignment this week. Like it's cool that we have this verification here and we get our data back, but we need some way to actually give this data to the rest of our application, the rest of our API that's actually doing the underlying logic so that it knows who is doing something. Like an example here would be if we wanted to say only an admin of our system is able to upload a new ice cream flavor. Then what we want to do is right when the request comes in for the first time in a middleware function, which we'll do in a second, um, we want to decode our token and make sure it's valid. And then with that user data, we're going to stick it onto the request within that middleware and then pass the request with that user data added onto it to our actual API endpoint. And now the endpoint knows that if I have gotten there, I have already checked that my user is real. They have authenticated. We have written the user data to the request object, and I can actually use that to check, okay, is this person an admin? Let me go check my database and see what roles this user has. So typically we'll do this as a middleware, which will reject as unauthenticated if the token doesn't exist or if it's been revoked. And then it does the decoding and sticks this onto the request data. Does that answer your question?
Yes, Sandy, I got you.
Yeah. I don't think we're going to do this as part of the ice cream shop demo, just because it requires us to like store extra MongoDB documents that I don't really want to do right now. But we'll go implement at least just the verification and the signing really quick, just to put this in a better context than this document. Other questions while we're here? let's try if we verify a token that is invalid. And then I rerun this. Nice. So instead of printing us our result body down here, it's going to give us a JWT error, JWT malformed. So I could try catch this. Cool. Let's try this one more time. So now we should properly catch this. And we print out 401 unauthorized invalid token and the error. And this is what we would probably send back to our user in that case. Let's also demo really quick what happens if we try and use a token that is no longer valid. So we're going to create a token that expires in 1 second. And we're going to, I guess sleep doesn't exist here. We'll do set timeout, which says after 5 seconds, we're going to execute some code. And then we'll stick all of this into our timeout. So after 5 seconds, then we're going to take our token, which should no longer be valid at this point, and try and decrypt it. Give it 5 seconds. Cool. And so now we have this error that the JWT has expired. And so it's no longer valid, still throws an error, and we know to reject it to the user as well. All right, this is great. Let's go thread this into our actual code, just so we can see that it works. I'm going to stop sharing for 1 sec and switch projects to our ice cream shop. All right. Let me reshare my screen. All right, so now I'm in my ice cream shop. This should look familiar. We have this middleware here, which does some really crude, not real authentication where it tries to pull the header and just make sure that it has a token. And if it has a token at all, then it'll just accept it and move it on. But we don't actually check if the token is valid. We don't issue tokens anywhere. And then we have our business logic down here where we have this get endpoint. And 2 weeks ago, we implemented some filters and query parameters to try and make this a little more useful and flexible. And then we have our endpoints down here for getting our stock and updating it. So I think what we're going to do is we're going to throw in some actual JSON web tokens to our authorization middleware up here. And then we're going to authorize specifically these routes, our get and our post and our patch, just to make sure that someone has to be logged in. Uh, as a side note, oftentimes at least at my job, these GET requests probably have lower requirements for interacting with the system than post and patch and put requests, since they're not actually changing anything about the system, it's just pulling down information. You may still want someone to authenticate with the system just so that any random Joe Schmo uh can't just like call your system 30 million times every second and take down your whole server without having some level of accountability. But you might choose to do that if you want to. Usually these post and patch requests that actually modify the server, those ones are you have to authenticate, you have to prove that you're a user, but then also you have to have certain levels of permissions. You have to be authorized to do it. We probably won't do any authorization, but we'll authenticate all three just to say that we did it. All right, so let's create a login route first. So what do we have here? We have our .env file. We're going to create our JWT secret. We'll just type in some random characters here. It doesn't really matter what. And we're going to npm install JSON web token. We already have .env, or at least we should. All right, and then what do we need to do here? So we have our Express server, we have our front end, we have our ice cream routes. Let's create a new router for user related things. We'll rename this to be ice cream router. And this will be user router. Which doesn't exist yet. We're gonna have to go create that. We'll copy paste this ice cream routes for now. And I'm gonna take the authorization out of the ice cream routes since it doesn't really belong there. And we'll leave just the business logic here. And here in our other one, which we're going to rename to user, we are going to take out the business logic and just leave our router with this authorization middleware. I'm realizing that this is actually not probably a good way to do this authorization middleware. So we're going to fix this in a second. Move authorization to a function. Use the middleware before any API calls. So right now we're sticking this on the router, which means that it's going to only apply to our user routes when really we want this to apply to everything. We want it to apply to our ice cream routes as well. So we're actually just going to make this a function for now. Authorize user. Or authenticate user specifically. And we'll leave the content the exact same, although to do verify the actual JWT. Let's start with our so let's start with our login endpoint first. Sorry, I'm just thinking about code organization and how I want to move all of this stuff. You know what? We're just going to create a separate package for this middleware because it doesn't really belong here. it belongs somewhere special. So we have our authenticate user function, and we'll export this as the default since there's nothing else in here. We'll come back to this in a second, but let's do our login first. So we have our router.get, sorry, .post /login async rec as. All right, so this is our actual API endpoint to log in. What's going to happen here? Well, username, password, rec.body. If our username is not defined or our password is not defined, then we're going to res.js or status 400 JSON missing username and /or password. Turn. And now that we have this username and password, let's put this into a token. Sorry, I'm getting my syntax all messed up with Golang, which I use at work. So we're going to do JSON web token. So we got to import it first. JWT dot sign. What are we signing? We're going to sign an object with the username. We don't need to put the password in there. We should not put anything that is sensitive information inside of our token, just because it's not necessary. If the token is verified and the token exists on our server, then we know that it is in fact the correct user. We only issued it if they got the password correct, so we don't really need the password after we undo the token. All we need is some identifier of the user information. Maybe in here we could like go get user from database and put user ID, user roles, etc. in the token. But for now, we're just going to sign our username. And then what do we need to do? We need to use JWT secret process.env.jwt secret. We'll just inline this directly. And what options do we want? We want this to expire in 1 day. And then we'll send this back to the user. They successfully logged in. Send JSON with the token. I don't know if this sign can fail or not. My guess is going to be no, because it doesn't tell us that we have to catch an error, but maybe we should catch an error here, just in case. This is one reason why I'm not a huge fan of JavaScript in the way that I used to be, that it's very difficult to know if something's actually going to give me an error or not. All right, we have our login endpoint here. let's open Postman and get this thing going. So what do we need? We need, oh, we already have our user router. So it should just work if I start up my server. Okay, start. Router is not defined. Ice cream router is what I renamed it to. Let's try it one more time. Cool. Our server is now running. It's up and running. We could use the front end if we want to, but we're just going to stick with Postman. Let's go to our ice cream routes and let's create a new collection. This one is user routes. We'll create a new post request. This one is our login. We have our local host. We're going to update this with user, login, and we're going to post a body of JSON. And let's see what this does. We need this to be post. We don't need to set an authorization header. We don't have a token yet, but we're going to get one back. Let's actually try this first, missing a password. It should send us back that we're missing something, which is what we expect. It gives us back a 400 error. And if I add this back, we now get our token back in a 200. So I will save this token to my routes collection while it is still valid. For our whole collection, we're going to say the authorization scheme is a bearer token. Our token is this thing that we just generated. So now all of our ice cream routes will have this token and inherit it from the parent. So we should now be able to authorize in all of those. So let's go back to our middleware really quick. So we have our authentication middleware. We have this header that gets stuck on everything. If our auth header is empty or it's not a bearer token, then we're going to say they are not authenticated. Someone might pass in a different authentication scheme. Another one that's pretty common is basic, where you pass literally just username and a password. So let's try user data is equal to G. I import it specifically here. So now we're going to JWT.verify. What are we going to verify? Token is strings. Dot split. This looks a little bit complicated, but what we're doing here is we're saying, given a string of the format, we're going to split the string in half by taking out this portion, and it'll leave us with two different pieces. It'll leave us with an empty string to the left, since there's no characters over there, and it will leave us with our token to the right. And so we get the first element there. We should probably even error handle this even better and make sure that there's a one element, but I'm relatively certain that there will be, since we just checked. So we're going to verify our token using process.env.jwt secret. We don't need any options. And if this is successful, Then we're going to call next after we set rec dot user is equal to user data. And if this doesn't work, then we're going to res dot status. This will be a 401 JSON error invalid token provided, and we'll stick on the error details there. So we now have a middleware that will grab our token, it will verify it. If it's successful, it'll stick it onto the request under a user field, which is not a generally defined piece of the HTTP request object in base JavaScript. This is some field that we're creating called user, and then we're going to stick the user data object on there. And then we're going to pass it to whatever the next request is, whatever needs to be authenticated before you can actually access it. So what do we want to do with that? We have our authenticate user middleware. Let's go into our ice cream routes and make sure that someone has to be authenticated before they can post and patch. So we're going to stick this middleware inside these two routes. We're going to import it. Middleware authentication.js. And we're going to leave the get out. So it does not need to authenticate before you can get. So let's do this. Let's check our GET request, which currently has authorization set. We're going to set this to no auth just for a second and send it. And we get back some data. It was totally okay. Let's actually get rid of all these filters just so it returns us everything. And let's try the same thing with our post request. So we set to no auth. We say that we're going to buy 1 scoop of strawberry ice cream. Now, if I send it, we're going to get an error not authenticated. Where does that come from? Well, that comes from our middleware up here, where we say if the token is not set in the request, we're going to reject it immediately with not authenticated. Now, what if they tried to do it with an invalid token? We have our post request, we have authorization, our bearer token. And let's say we have bearer, but some invalid thing. We send the request. Ooh, token is not defined. Where did I try and use token that I'm not able to? Authentication.js 7. Oh, um, let me explain really quick. This variable doesn't exist at this scope. Previously, we had like hard-coded a very specific token, but we no longer want to do that. All we want to do here is check that this string is a bearer token. So instead, what we're going to do is say if auth.starts with bearer. So if it does not start with bearer, then we're going to reject it. But if it does, then we're okay. So let's try it one more time. Not authenticated. All right, so there's no colon here. It should just be bearer and then a space. And this token should just be foobar. The bearer postman is going to stick on for us. All right, invalid token provided, JSON web token error, JWT is malformed. So we got bearer foobar. It did actually get through this clause, but then it tried to split it and verify it, but the verification failed. And so we jump down here and we reject it with an invalid token. Now, if I go to the inherited token, which is from this ice cream routes collection, we stuck the token in there that we issued. And now I send the request again with a correct token. We should see that our request was accepted. Similarly, for our GET request, if we were to stick like a bearer token in there inherited from parents, it should work. It doesn't actually check this token anywhere, so I could also give it some invalid token that is nonsensical, foobar, and this one will actually be okay because it's never checking that token. But we do not need to inherit this token since our GET request is not actually looking for it. All right, we're out of time here. There's some interesting extensions that you could do to this if you want to. We talked about revoking tokens earlier. It would be a good thing to update maybe your MongoDB collection to store users and their tokens that they've been issued. You could even put that all in one model together. Just have like the user and then a list of valid tokens that have been issued. And then do that revoking. That would be a good stretch goal. You could add roles to a user and say this user is an admin, this user is just a regular user, and then maybe inside of our business logic, after we've already authenticated, inside of our business logic, we could say, all right, so if rec.user, which we know is a valid property. Let's actually prove that this is valid really quick. I promise I will let you guys go in 1 sec. So we could say like if rec.user.roles dot contains admin. This is not valid JavaScript, but you get the idea. Then we would reject with a 401 or something like that. But this user data is now where we would check if the user is a real person and who that person is so that we can do more things in the future. Let's test this really quick just to see that it works. If I do my GET request, which does not authenticate the user, then we're going to see that it prints undefined. This is not a valid user. And then if I do my post request and I send that, then you're going to see that it prints this user data up here, what was decoded and then stuck onto the request. So you could do something like this, stick the roles onto the JWT or look them up in your database if you want to, and then reject it. Or another thing you could do is start like implementing the login endpoint more thoroughly than what we did here and actually like check, is this user, like, is their password correct? You could store their password securely using hashing. There's a library for this, or you can implement your own strategies. There's lots of ways of doing it, but lots of ways you can go from here, which maybe we'll get to in a future week, but we'll leave it here for now. As usual, I'll stick around for a couple minutes for questions. Make sure you do the sign-in form before you leave, and I will plan to see you guys next week. Have a great weekend.